We'll start with questions from the homework or whatever. Does anybody have anything they want to talk about? Lucas. 18? Sure.
Hold on, we didn't do the homework? I know I laughed.
So, stop talking, please, guys. Is this what you wanted or no? Okay. On 18, we're asked to sketch a graph of the function, making sure to include the vertical asymptotes, horizontal asymptotes, zeros, and y-intercepts. So we'll start with the vertical asymptotes. We get those by setting the denominator equal to 0. So I have a vertical asymptote at -2. The zeros we get by setting the numerator equal to 0. The y-intercepts we get by plugging 0 in for x. And then the horizontal asymptote or slant asymptote, we're going to get by, we need to look at the degree, right? So this is degree 1. The denominator is degree 1. Stop talking, please. Thank you. When we have equal degrees, we find a horizontal asymptote by looking at the leading coefficient of the numerator over the leading coefficient of the denominator. So there's my key features that they asked for. Start sketching a picture out then. So daisy. Got my vertical asymptote here at -2. My horizontal asymptote at +2. I have -1.5 as my y-intercept and +1.5 for my x-intercept. So from there I can tell pretty easily that to connect those 2 points and follow the asymptotes, I got to have that part of the graph looks like that. What I need to figure out now is the other arm of my graph going to be starting pointing up or pointing down? So I'll do that numerically. So I'm going to go ahead and type in my equation into my calculator. And I'm just going to look at some values of y as we get that are less than -2 but are getting progressively closer to -2. When I do that, I see that the y's keep getting bigger and bigger and bigger. So that tells me the graph is pointing up. So I should be doing that. And that's it. Does that feel okay, Lucas? That's a good one to talk about. It looks like I kind of missed the function down here. You'll forgive me, I guess. Sometimes it's hard to connect those dots. Especially when you're drawing on a computer screen. You know? It's hard. Oh, what else you guys want to talk about? I'm happy to do some more. Cheyenne?
Nothing specific, but can you just go over like one of the more questions from last class because I wasn't here?
Sure. Does anybody else have one of those 25 through 34s that they're interested in?
Just one of these.
Okay. Figured I'd see if we could double dip one. I'm just going to pick 32. So what I'm going to do is I'm going to start by factoring all the denominators. So the other two denominators are prime. There's nothing to do there. And then I want to multiply both sides of this equation so that there won't be any denominators left when I'm done. So if I multiply by x minus 2 times x plus 1, that ought to do it. So the first fraction, when I multiply it, have that. The second fraction, and then at the end, the last fraction, I have this. Now I can reduce each one of these. And by reducing each one of these, I no longer have fractions anymore. All the denominators canceled out. So now I'm just going to multiply things out and try to solve the resulting equation. So what I notice that I have left is a quadratic equation. So I'm going to combine my like terms and set it equal to 0 by subtracting 15 from both sides. To solve this resulting quadratic equation, I could either try to factor this or use the quadratic formula. Since the leading coefficient is not 1, I know if I want to try to factor it, it's going to be kind of that longer factoring method. As a result, I'm not really interested in going down that road. I'm just going to use the quadratic formula because I'm guaranteed an answer. I don't think it's any more work than trying to do that long factoring piece, even though I know that this does indeed factor. So negative 1 squared is 1. Negative 4 times 3 times negative 10 is 120. 1 plus 120 is 121. The square root of 121 is 11. 1 plus 11 is 12 over 6, or 2. And then 1 minus 11 is negative 10 over 6, which reduces down to negative 5/4. But I'm not done. So I still need to check these answers. The way that I check the answer is I'm going to take the solution and plug it back into the original equation and see if I get a 0 denominator anywhere. Well, I would definitely get a 0 denominator with the negative, or with x equals 2. So that's not a solution. That one is extraneous. However, if I plug negative 5/4 in there, that one will definitely work. So that one is the only solution I'm left with. Ava?
Which equation are you plugging back into?
The original. I'm going to look at the factored form of the original, but the original before I cleared the fractions. Cheyenne, does that feel Okay. The secret of these like algebra 2 topics is that everything is really just a quadratic. Where like all these problems just kind of turn into a quadratic equation at one point. Just like, do you know the preamble to get down to that? Okay, let's start in with today's stuff. Let me actually do this a little bit. So Friday, we're going to plan on doing the homework quiz. Homework quiz is going to be on the 14.1 stuff on Friday. So you should be able to, given a rational function, find vertical asymptotes and removal discontinuities, x-intercepts, y-intercepts, horizontal or slant asymptotes. And if I give you that kind of information, you should be able to draw a graph. So if I tell you, okay, this has got a vertical asymptote here and here, and this horizontal asymptote, and these x-intercepts and y-intercepts, and this kind of end behavior, you should be able to kind of like draw that picture out for us. What do you guys think? Clear enough as to what to do? Okay. Today, we're going to do an off-book topic. This is something ideally you would have done in your Algebra 2 class, but you guys have told me repeatedly you didn't get that far in your Algebra 2 class, so we're going to do it now because it fits in quite nicely with what we're doing as it's about rational functions. So today we're going to talk about multiplying and dividing rational functions as well as adding and subtracting rational functions. So we'll start with the multiplying and dividing piece, specifically multiplication. And the analogy that I'm going to use is just going all the way back to elementary school and talking about how we multiply fractions. So if I have something like 18 over 20 times 25 over 81, what do we want to do to multiply something like this? We want to reduce and then multiply. Very good. So to reduce, what are we going to have to do? Well, ideally, to make sure we get all the reducing, we want to do a prime factorization, right? So 18 is 2 times 3 squared. 20 is 2 squared times 5. 25 is 5 times 5. Well, yeah, let's write them, actually. I'm going to write it without the powers. I'm going to just write 18 as 2 times 3 times 3. And then 20 is 2 times 2 times 5. And then 25 is 5 times 5. 81 is 3 times 3 times 3 times 3. So far, so good? Now I can reduce. So anything from the top could reduce with something from the bottom. And when I cross these out like this, when I reduce these, what do these numbers become when they get crossed out? They don't become 0, 1. Why do they become 1s? Because like 2 divided by 2 is just 1, right? So the numerator really I have 1 times 1 times 1 times 1 times 5. And in the denominator I have 1 times 2 times 5 times 3 times 3 times 3, or 18. And there we go. Is everybody okay? Remember doing this? The nice part about what we're doing today with these rational functions is everything we're about to do, the procedure is the same for fractions. So it's the same procedure, but we have to update what we're doing so that it fits with a polynomial instead of just a number. But that's okay. It's the same idea. So let's say we have x squared plus 5x plus 6 divided by x squared minus x minus 6 times x squared minus 4x plus 3 over x squared plus x minus 2. Ooh, that's a mouthful. What's the first thing I need to do on this? What's the first thing we did before? Reduce, but to reduce, what do we have to do? We had to factor, right? So let's start by factoring here. How does x squared plus 5x plus 6 factor? Okay, so x plus 3 times x plus 2. How about x squared minus 6x minus 6? Negative 3 and positive 2. Very good. Okay. And then x squared minus 4x plus 3, how does that factor? Negative 3 and negative 1. Very good. You guys should all be shouting these out, though, right? This was the one skill you told me we did excessive amounts of practice with last year. We should still be able to do this quite well, right? And the last one, x squared plus x minus 2. Negative 1 and positive 2. Good. Okay. Now it's time to reduce. Let's see, what can reduce? These x plus 2's can reduce. These x minus 3's can reduce. And those x minus 1's can reduce. So we're left with x plus 3 over x plus 2. So far, so good. Is that the end? Are we done? Are those, right? That's over. We did it. We reduced, we multiplied. There's nothing more to reduce. Seems like we should be done, right? What? Elise, you said what? You want to reduce the x's here? We cannot. Why can't we reduce the x's? What operation is going on between the x and the 3? Addition. So if I think about, like, if I have 5 plus 3 over 5 plus 2, that should be 8 over 7, right? If I reduced like that, I'd get 3 over 2, which is not the same. So I definitely know I can't reduce like that. It has to be multiplication to do the kind of reducing that we've been doing. Does that feel okay, Elise? And that's an important observation to make. Like, if you can't keep straight when you can reduce and when you can't, this is going to be a nightmare. So, like, that's an important question, an important thing to note. It turns out that this is not completely correct, what we've written. So here's the deal. If these two things are equal, what we started with and what we ended with, I should be able to pick any value of x, say 3, and if I plug it in to this and plug it into the end, I should get the same number to come out, right? Everybody agree with that? So if I plug in 3 to the top, I get 30 over 0 times 0 over 10. That's 0 over 0, which is undefined. If I plug in 3 over here, I get 6 over 5. Uh-oh. Those are not the same. If I picked, say, 0, that works because I get just 6 over negative 6 equal, or times 3 over negative 2, which is just 3 over 2 for both of them. So it seems like we kind of got it. But not every number is working. So the question is, or the way we're going to complete this is we're going to list those values of x that didn't work. So Mr. Kulik found one of them for you with a 3. How are we going to find the other values of x that don't work? Well, it's really easy. The answer is all right here in this work. X minus 3. That gave me a 3. X plus 2, what's that going to give me? A negative 2. And then x minus 1, what's that going to give me? 1. That's the answer now. What does that remind you of? From 14.1? It's just like the removable discontinuities, right? This is exactly the same way we find the removable discontinuities. Whatever you reduced completely from the denominator, you set equal to 0 and solve, gives you the removable discontinuities. We're doing the exact same thing here. So these would be like the restricted values or whatever you might call those, right? What do you guys think? It's not too bad, right? You factor and you reduce and you're basically done. What if we talk about division now? Let's go back in time, back to our elementary school. How did we divide fractions? Like 18 over 20 divided by 81 over 25. Multiply by the reciprocal. That's correct. So I'm just going to turn this into a multiplication problem. And hey, wait a tick. We already did that multiplication problem. I chose the problem intentionally so I didn't have to do the work again, because the point of it was I wanted to remind you that every division problem is just a multiplication problem. So we're going to do the same thing now with our rational function. So let's say we have x squared minus 4 over x squared minus 5x plus 6 divided by x squared plus 5x plus 6 over x squared minus 9. So let's start by factoring. And at the same time, I'm going to make the reciprocal and turn it into a multiplication problem at the same step. Is everybody okay with that? Just saves a lot of writing to do it both at the same time. Okay, so how does x squared minus 4 factor? Oh, this is taking too long. Very good. X plus 2, x minus 2. That's just like the difference of two squares is what we call that one. And then how do we factor x squared minus 5x plus 6? -2 and -3, I think you said. Now we're going to change this to multiplication problem. So what goes on top? The x squared minus 9 factors, right? How does x squared minus 9 factor? -3 and +3. Good. And then the denominator then is the x squared plus 5x plus 6. How does that factor? We did it already, right? 3 and 2. Okay. So now we're going to reduce. So x minus 2 is canceled. X minus 3 is canceled. X plus 2 is canceled. And x plus 3 is canceled. Oh, everything is gone. What's this equal then? 1 is correct. Almost. What do we still need, though? The restricted values. That's the term you're searching for. Yep, exactly right. What are the restricted values going to be here? 2, 3. Okay, so I'm just going to write it as that way. You could write them as 4 separate things. That's okay also. I'm just conserving ink. There's no ink here. Conserving electrons. That's funny because the electrons are being used whether I'm writing it or not. Maybe not the ones in my pen. Maybe there's some more in the battery in my pen anyways. Lithium ions, I think then, right? That's the kind of battery that's probably powering this thing. You guys are all just like, stop talking about this. Okay. Let's transition to adding and subtracting then. Just like before, I'm going to start with how we do this just for regular old fractions like we did back in elementary school and show you that we're going to still use the same process. So let's say we want to take 5/6 minus 7/18 plus 11/24. In order to add and subtract these things, what do I need? A common denominator. And optimally, I don't want just any old common denominator. To make this as easy as possible, what do I want? The least common denominator. Excellent. Great. How do I find that least common denominator? So we're going to be using the least common multiple of the numbers 6, 18, and 24. The easiest way to find that least common multiple is to look at the prime factorization of those numbers. 6 is 2 times 3. 18 is 2 times 3 squared. And 24 is 2 squared times, is 2 to the third times 3. Everybody's okay there? So the least common multiple of those 3 numbers is going to have to contain any distinct prime factor of 6, 18, or 24. What are the distinct prime factors of 6, 18, or 24? 2 and 3. Now what I'm going to do is I'm going to look at the powers of 2. So I have a 2 to the first, 2 to the first, and 2 to the third. The power of 2 in my least common multiple needs to be the maximum of the powers in each individual denominator. So the biggest exponent on a 2 is 3. So I have 2 to the third. I'm going to then do the same thing for the 3's. I have a 3 to the first, 3 to the second, and 3 to the first. So the exponent of 3 in my least common multiple should be to the second. Everybody okay with what I've done now? Now what I need to do is I need to figure out what do I need to multiply 5 over 6 by so that I get that least common multiple 2 to the third times 3 squared. Right? So the easiest way to do that is to look at what I have and then look at what I want. So I have 1, 2. How many more 2's do I need to get to that least common multiple? I need 2 more, right? I have 1, 3. How many 3's do I want? 2 of them, so I'm going to need 1 more. So now I'm going to look at 7 over 18. Again, I'm going to compare what I have with what I want. So I have 1, 2. I need 3 2's, so I'm going to need 2 more 2's. I have 2 3's, and I want 2 3's, so that's all I need. Everybody okay there? And then for my last one, I'm going to compare what I have to what I want. I have 3 2's, and I want 3 2's, so I don't need any more 2's. I have 1 3, and I want 2 3's, so I'm going to need 1 more 3. Sophia? Certainly. Everybody okay with what I did there so far? Okay. So that's going to be, can I reduce here? First things first, let's ask that question. No! Why not? What's going on in that numerator that's preventing me from doing any reducing? Yeah, the multiplication or the addition subtraction that's going on up there. So what am I going to do? I'm just going to multiply everything together and add and do the addition and subtraction. So 5 times 2 squared times 3 is 60. 7 times 2 squared is 28. 11 times 3 is 33. So I end up with 65 over 8 times 9 is 72. And I should check to see if I can reduce that, right? 65 is 5 times 13. The denominator doesn't have any factors of 5 or 13, so I know that's as good as I can do. Okay. Let's do this now with rational functions. So let's say we have x plus 5 over x squared plus 3x plus 2 plus 7 over x plus 2 minus 2x over x squared plus x. All right. what do I want to start by doing? Factoring. Great. So if I look at the numerators are all prime, right? So there's no factoring I can do with the numerators. So we'll just worry about the denominators. How do I factor x squared plus 3x plus 2? X plus 2 and x plus 1. X plus 2 is prime, so there's nothing to do there. And then how do I factor x squared plus x? What'd you say? I thought you were saying something correct. Close. Yeah, there you go. Perfect. All right. So the least common multiple of these things is going to be, need to include each distinct prime, right? How many distinct prime factors do we see? You should see 3. We see an x plus 2. We see an x plus 1. And we see an x. Everybody okay with that? So what do I need to multiply x plus 5 over x plus 2 times x plus 1 so that I get that least common multiple in my denominator? I have the x plus 2. I have the x plus 1. What am I missing? The x. Can we pause for one quick second? Why didn't I worry about the exponents on any of these things? Everything was to the first, right? So if everything is just to the first, there can't be any powers, right? Because it's just the biggest exponent and they're all the same. So they're all just ones. I should have said that expressly instead of just motoring past. So I wanted to pause and say that now. Okay. What do I need to multiply 7 over x plus 2 by to get that least common multiple? X plus 1 and x. So I'll write it that way. Is everybody okay there? And what do we need to multiply 2x over x times x plus 1 by to get that least common multiple? X plus 2. Everybody feel okay with what we've done so far? Do I need to pause for a minute and let you process and catch up? If your pencil's on fire, let me know. Okay, so maybe not. So now what I'm going to do is I'm going to multiply. Let's use a different color here, Kulik. Got lots of colors. The numerator's out. Oops. So that's what I got. How's that look to you guys? You should object to this because it's incorrect. I've made a mistake intentionally because it is the most common mistake I see students make on these kinds of problems. Take a moment and see if you can see it. If you can't, that's okay. I'll tell you what it is. And then you go, ah. Nope, that's correct. Nope. Okay, here it is. I really am not multiplying 2x. I need to multiply negative 2x. So that should be a negative 4x there at the end. That negative sign needs to distribute with the 2x. Woof, Mr. Kulik. I'm going to forget to do that. I know, but I'm going to keep showing you that same mistake and making it all the time. So hopefully you do a good job looking for it when it's finally time to do these on your own. All right. Can I reduce at this step where I'm at? No. What do I need to do? Combine like terms. So the x squareds can go together. That'll give me a 6x squared. The x's can go together. That'll give me a, what's that, 8x. Can I reduce at this step? Well, not quite yet. What do I need to do in order to reduce? Got to factor the numerator, right? How do I factor 6x squared plus 8x? I can take out a 2x. Good. Anything to reduce? Yeah, there is. The singleton x. And because I did that reducing, I do get a restricted value when I set the x equal to 0. So that is what caused the restricted value. And that's fine for me, leaving our final answer in factored form. No sense in multiplying that out. Now, can I point out to you guys something? I let this go because nobody noticed it. But there was a shortcut that would have simplified this problem a little bit that we missed way back in the very beginning. Let's go back and look at the factored version. Look at this last factor. 2x over x times x plus 1. What do you notice? Could have reduced there, which saves us an x in our least common multiple, and like kind of a lot of symbols along the way. That would have sped things up just a little bit. So don't be afraid before you start making your least common denominator. Just check really quick to see if you can do any reducing in any of the fractions, because it will make life easier if you catch it. In this case, it was just a factor of x, so it wasn't that big of a deal. But if it was like a linear fact, or like an x plus 7 or something, boy, that would have saved you a lot of headache. You know what I mean? Anyways, I'm going to erase all this stuff because the work we didn't do that. That was just like a in hindsight. All right. I got one more for you guys, and then we're going to call her quits for today. Matthew. Of course. You can go too. It's fine. Don't act like it was a race. It's okay. Some people really care. I don't really care. Cool. All right. Last example. What do we want to start by doing? Factoring. X minus 2, that's prime. Can't do anything with that. How do I factor x plus 4 times, or x squared plus 4x plus 4? X plus 2 and x plus 2. Now, for our purposes, it's going to be very important that we write it x plus 2 squared that way. Because if we don't, we're likely to goof up our least common multiple. So it's really important that I don't write that as x plus 2 times x plus 2, but I write as x plus 2 squared. All right. So I look at my next fraction. I notice, hey, I can factor both the numerator and the denominator here, right? How do I factor the numerator? Two x squared plus x. Yeah, just take an x out. And the denominator, x squared plus 2x. Just take an x out. And what do we notice there? Yeah, let's not make that same mistake twice. Let's check to see if we can reduce. That's nice. And then my last one, 7 over x squared minus 4. How does x squared minus 4 factor? X plus 2, x minus 2. Okay, so what's my least common multiple going to be here? X plus 2 and x minus 2. Okay, those are the distinct factors. Now we have to look at the exponents. The biggest power on x plus 2 is 2. And the biggest power on x minus 2 is just 1. So that's our least common multiple. Everybody feel okay so far? Okay. What do I need to multiply the first fraction by to get that least common multiple? X minus 2. And what do we need to multiply the second fraction by to get that least common multiple? X plus 2, not squared, just to the first, and x minus 2. Because x plus 2 times x plus 2 is x plus 2 squared. We already got one of them, so we just need one more. And then the last one, what do we need to multiply 7 over x plus 2 times x minus 2 by to get that least common multiple, or denominator? X plus 2. Very good. So far, so good? Everybody still hanging in there? All right. So I'm going to FOIL out that numerator. I'm going to FOIL here. And then FOIL there. and then just distribute this one. What do you guys think? Does that look good to you? So far, so good? Double check me, see if I made any mistakes. I did. On purpose. That's the mistake that I did intentionally. Again, with the subtraction symbol, Mr. Kulik, you warned me that I was going to make that mistake a bunch of times over and over and over again to make sure that I knew to look for it. I wasn't looking, and you caught me not looking. I know, guys. It'll get there. Oof. And then what was that? That was just like a not intentional mistake there. Forgot to multiply the 2 and the 7. Yeep! All right, so combine some like terms now. So we have negative 2x cubed. X squared's canceled. I have 11x and then 22. My last thing I need to do is check to see if I can reduce this, right? In order to reduce this, what would I have to do? Factor the numerator. But look at the numerator. It's an x cubed. Do I know how to do anything with that? I don't have any good ideas on what to do with that. Or just call it good. What do you guys think? Worst part is, some of these are a lot of writing. The idea is easy enough. It's like the same thing we did in elementary school with adding and subtracting fractions. But its organization becomes a critical factor in getting these correct, where you're able to like keep your work neat and easy to read so you can copy one step to the next step to the next step and not get lost in the sauce, so to speak, right? So if you are a messy kid, a messy writer, a messy worker, this will be a challenge for you to kind of keep yourself organized enough that you're able to follow what you're doing from one step to the next step to the next step. If you're very neat and precise and organized, this will go a lot smoother. So if you're a messy individual, know yourself enough that like, I just need to slow down and be careful, maybe write more than I usually do, try to write everything linearly, like in a row, so it's easy for you to follow. So your assignment, I have 2 worksheets for you to do. So in this first one, there's just some simplifying stuff to do, and then transitions into some multiplication division stuff. And my next worksheet, I have addition and subtraction stuff for you guys to do. But this seems like too much stuff to ask you to do all of this all at once, because that's like 50 problems or something. So just do the odds. And then on worksheet 3, don't worry about these critical thinking questions at the end. So just do the odds from worksheets 2 and 3. I put 4 of these in here. I'm not sure we're going to do all 4 of them. So right now we're just doing 2 and 3 and just the odds from those. We might come back and do the evens as a second pass, depending on how you guys think things went, right? Maybe next time we'll go through and just have you guys say what answers you guys got. We'll decide whether it's right or wrong. Get you some individualized, semi-individualized feedback, and then we'll decide whether, that didn't go great. Maybe we should try the evens after doing some of these more practiced. We'll play it by ear.